When installing multiple grounding conductors within a polyvinyl chloride or PVC conduit, all conductors must be considered when calculating conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. This calculation is crucial because exceeding the allowable fill percentage can lead to overheating of the conductors, insulation damage, and potentially hazardous conditions. The National Electrical Code, or NEC, provides guidelines on conduit fill in Article 310.15 in Chapter 9. These guidelines aim to ensure adequate heat dissipation and prevent damage to conductors. When multiple grounding conductors are present, they contribute to the overall fill, even though they do not typically carry current under normal operating conditions. The impact of multiple grounding conductors on conduit fill necessitates careful consideration of ampacity derating. Ampacity refers to the maximum current a conductor can carry continuously without exceeding its temperature rating. When multiple current-carrying conductors are installed in a conduit, their ampacity must be derated according to NEC Table 310.15 current. This derating factor reduces the allowable current to account for the increased heat generated by the conductors in close proximity. While grounding conductors are not current-carrying under normal circumstances, their presence in the conduit contributes to the overall heat built-up. Therefore, the NEC requires that they be counted when determining the number of conductors for ampacity derating purposes. This ensures that the conductors are not overloaded and that the installation remains safe. To properly size a conduit with multiple grounding conductors, you must first determine the total cross-sectional area of all conductors, including the grounding conductors. This can be done using the dimensions provided in NEC Chapter 9, Table 5 and Table 5a. Once you have the total cross-sectional area, you can use NEC Chapter 9, Table 4 to determine the minimum conduit size required to accommodate all conductors. It is important to note that the NEC specifies different fill percentages for different types of conduits and wiring methods. For example, the allowable fill percentage for a single conduit may be different from the allowable fill percentage for a nipple. Therefore, it is essential to consult the appropriate NEC tables and sections to ensure compliance. In addition to conduit fill and ampacity derating, there are other considerations when installing grounding conductors in PVC conduit. Firstly, the grounding conductors must be properly sized according to NEC Table 250.122 based on the size of the overcurrent protective device protecting the circuit. Secondly, the grounding conductors must be securely connected to the equipment grounding busbar in the panel board or service equipment. Thirdly, the grounding conductors must be continuous and unbroken throughout their length. Furthermore, it is crucial to select the appropriate type of PVC conduit for the application. There are different types of PVC conduit available, each with its own temperature rating and suitability for different environments. For example, Schedule 40 PVC conduit is commonly used for general-purpose applications, while Schedule 80 PVC conduit is used for applications where greater physical protection is required. When installing PVC conduit, it is important to follow the manufacturer's instructions for cutting, joining, and supporting the conduit. PVC conduit should be cut with a fine-tooth saw or a specialized PVC cutter to ensure a clean, square cut. The conduit should be joined using PVC cement and fittings that are specifically designed for use with PVC conduit. The conduit should be supported at regular intervals using conduit straps or clamps to prevent sagging and damage. In summary, when installing multiple grounding conductors in PVC conduit, it is essential to count all conductors when calculating conduit fill and determining ampacity derating. This ensures that the conductors are not overloaded and that the installation remains safe and compliant with the NEC. Additionally, proper conduit sizing, grounding conductor sizing, and installation practices are crucial for a reliable and safe electrical system. Firstly, always refer to the latest edition of the National Electrical Code, or NEC, for the most up-to-date requirements and guidelines regarding grounding conductors and conduit fill. Secondly, consult with a qualified electrical engineer or licensed electrician if you have any questions or concerns about the proper installation of grounding conductors in PVC conduit. Thirdly, ensure that all work is performed by qualified personnel who are familiar with the applicable codes and standards. When calculating conduit fill with multiple grounding conductors, the following steps can be taken. 1. Identify all conductors that will be installed in the conduit, including the grounding conductors. 2. Determine the cross-sectional area of each conductor using NEC Chapter 9, Table 5 and Table 5a. 3. Calculate the total cross-sectional area of all conductors by summing the individual cross-sectional areas. 4. Determine the inside diameter of the conduit being used. This information can be found in NEC Chapter 9, Table 4. 5. Calculate the allowable conduit fill percentage based on the number of conductors and the type of conduit. Refer to NEC Chapter 9, Table 1 for the allowable fill percentages. 6. Calculate the maximum allowable fill area by multiplying the inside area of the conduit by the allowable fill percentage. 7. Compare the total cross-sectional area of the conductors to the maximum allowable fill area. If the total cross-sectional area exceeds the maximum allowable fill area, a larger conduit size is required. When derating the ampacity of conductors in a conduit with multiple grounding conductors, the following steps could be taken. 1. Determine the base ampacity of each conductor based on its size and insulation type. Refer to NEC Table 310.16 for the ampacity ratings of conductors. 2. Determine the number of current carrying conductors in the conduit. Remember to include the grounding conductors in this count. 3. Refer to NEC Table 310.15 current to determine the ampacity adjustment factors based on the number of current carrying conductors. 4. Multiply the base ampacity of each conductor by the applicable adjustment factor to determine the derated ampacity. It is also important to consider the impact of ambient temperature on the ampacity of conductors. NEC Table 310.15 cone provides ampacity correction factors for different ambient temperatures. If the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, the ampacity of the conductors must be further derated using the correction factors provided in the table. Furthermore, it is crucial to ensure that all grounding conductors are properly identified. NEC Section 250.119 requires that grounding conductors be identified by a continuous green color or a continuous green color with one or more yellow stripes, unless it is bare. This helps to distinguish grounding conductors from other conductors and prevents accidental misconnections. In addition to the NEC requirements, local codes and regulations may also apply to the installation of grounding conductors in PVC conduit. It is important to consult with a local authority having jurisdiction, or OJ, to ensure compliance with all applicable codes and regulations. Properly installing grounding conductors in PVC conduit requires careful attention to detail and a thorough understanding of the NEC and other applicable codes and standards. By following the guidelines outlined in this narration, you can ensure that your electrical installation is safe, reliable, and compliant. Remember to always prioritize safety and consult with qualified professionals when necessary. Firstly, ensure the proper selection of grounding conductors. Grounding conductors must be sized appropriately based on the size of the overcurrent protection device protecting the circuit they serve. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors. It is crucial to select conductors that are large enough to safely carry fault current back to the source, ensuring proper operation of overcurrent devices and minimizing the risk of electrical shock. Secondly, consider the type of grounding conductor. The NEC recognizes various types of grounding conductors, including copper, aluminum, and copper-clad aluminum. The choice of conductor material depends on factors such as cost, conductivity, and environmental conditions. Copper is generally preferred for its excellent conductivity and resistance to corrosion, but aluminum may be used in certain applications provided it is properly sized and installed. Thirdly, be careful to choose the right PVC conduit. PVC conduit is a popular choice for electrical installations due to its lightweight, durability, and resistance to corrosion. However, it is essential to select the appropriate type of PVC conduit for the specific application. Schedule 40 PVC conduit is commonly used for general-purpose applications, while Schedule 80 PVC conduit is recommended for applications where greater physical protection is required, such as direct burial or exposure to mechanical damage. Fourthly, pay attention to the installation of PVC conduit. Proper installation of PVC conduit is crucial for ensuring the long-term reliability and safety of the electrical system. The conduit should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. This includes properly supporting the conduit, using approved fittings, and sealing the conduit to prevent moisture ingress. Fifthly, the need for expansion fitting should be remembered. PVC conduit is subject to thermal expansion and contraction, which can cause stress on the conduit and fittings if not properly addressed. Expansion fittings are designed to accommodate this movement, preventing damage to the conduit system. The NEC requires the use of expansion fittings in certain applications, such as long runs of conduit or installations where the temperature variation is significant. Sixthly, grounding bushings and bonding jumpers must be installed. Grounding bushings and bonding jumpers are used to ensure a continuous electrical path between metal enclosures and the grounding conductor. These devices provide a low impedance path for fault current, minimizing the risk of electrical shock. The NEC requires the use of grounding bushings and bonding jumpers in certain applications, such as when connecting metal conduit to metal enclosures. Seventhly, proper labeling is necessary. Proper labeling of electrical components is essential for safety and maintenance purposes. All conduits, junction boxes, and enclosures should be clearly labeled to indicate their function and the circuits they serve. This helps to prevent accidental misconnections and facilitates troubleshooting. Eighthly, regular inspections are a good idea. Regular inspections of electrical installations are crucial for identifying potential problems and ensuring continued safety and reliability. Inspections should be performed by qualified personnel and should include a thorough examination of all components, including grounding conductors, conduits, and fittings. Any identified problems should be promptly addressed to prevent further damage or hazards. Ninthly, documentation. Maintaining accurate documentation of electrical installations is essential for future reference and maintenance purposes. Documentation should include drawings, specifications, and test reports. This information can be invaluable for troubleshooting problems, making modifications, or planning future upgrades. Tenthly, consider the need for surge protection. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes or other transient events. SPD should be installed at the service entrance and at sensitive equipment to prevent damage and ensure continued operation. By following these guidelines and paying close attention to detail, you can ensure that your electrical installation is safe, reliable, and compliant with all applicable codes and standards. Remember to always prioritize safety and consult with qualified professionals when necessary. Firstly, you need to understand the basic principles of grounding. Grounding is a fundamental safety measure in electrical systems designed to protect people and equipment from electrical shock and damage. It provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. Secondly, it is important to differentiate between equipment grounding conductors and grounded conductors. Equipment grounding conductors, or EGs, are used to connect metal enclosures and other non-current carrying metal parts of electrical equipment to the grounding system. Grounded conductors, also known as neutral conductors, are used to carry current back to the source under normal operating conditions. Thirdly, be careful of sizing equipment grounding conductors. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent device. It is essential to select conductors that are large enough to safely carry fault current back to the source, ensuring proper operation of overcurrent devices and minimizing the risk of electrical shock. Fourthly, think about the materials used in grounding conductors. Grounding conductors can be made of copper, aluminum, or copper-clad aluminum. Copper is generally preferred for its excellent conductivity and resistance to corrosion, but aluminum may be used in certain applications provided it is properly sized and installed. Fifthly, consider the types of grounding electrodes. A grounding electrode is a conducting object that is used to establish a connection to the earth. The NEC recognizes various types of grounding electrodes, including metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rods. The choice of grounding electrode depends on factors such as soil conditions, local codes, and the availability of suitable electrodes. Sixthly, when you are installing ground rods, be wary of doing it correctly. Ground rods are a common type of grounding electrode used to provide a connection to the earth. They are typically made of copper or copper-clad steel and are driven into the ground to a depth of at least 8 feet. The NEC requires that ground rods be installed at least 6 feet apart and that they be connected to the grounding system with a continuous grounding conductor. Seventhly, be sure that all connections are secure. All connections in the grounding system must be mechanically and electrically sound. Connections should be made using approved connectors and should be tightened to the manufacturer's specifications. Loose or corroded connections can increase the impedance of the grounding path, reducing its effectiveness and increasing the risk of electrical shock. Eighthly, remember the importance of bonding. Bonding is the process of connecting metal parts of electrical equipment to the grounding system to create a low impedance path for fault current. Bonding is essential for preventing voltage differences between metal parts, which can cause electrical shock. The NEC requires that all metal enclosures, raceways, and other metal parts of electrical equipment be bonded to the grounding system. Ninthly, when dealing with metal water pipes, bond them properly. Metal water pipes are often used as grounding electrodes, but they must be properly bonded to the grounding system to ensure a continuous electrical path. The NEC requires that metal water pipes be bonded within 5 feet of their point of entrance to the building. Tenthly, remember that all gas pipes can never be used as grounding electrodes. Gas pipes should never be used as grounding electrodes because they can create a dangerous explosion hazard. The NEC specifically prohibits the use of gas pipes as grounding electrodes.